Hello, my name is Fazrul and welcome to our video on noise level measurement. We carry out our noise level test at Tanjung Sini. Before we get started, I would like to take a moment to introduce my team members.
Oh wow!
Today I'm going to talk about sound in building design. Sounds happens when something vibrates and moves through air or solid materials. In buildings, it affects comfort and how well people can work or communicate. If sound is not controlled, it can cause distraction like noise from footsteps, voice or falling objects going through walls and floor. That's why it is important to understand how sound works and how to manage it so we can create a quieter and more comfortable environment.
Hi, my name is Valerie Jasmine, and now I'm going to explain about the equipment and the application of the apparatus. So first, let me briefly explain what is the equipment and the apparatus. The function of equipment is to ensure that the noise is accurately recorded to aid in assessing the noise exposure, to confirm that the noise was adhered to follow the regulation, and to apply measures to protect people from excessive noise. So the first thing is tripod. Tripod is a stand that is used to support camera and other apparatus that usually come with 3 legs. And the function of tripod in this report is to act as the support to mobile phone, which acts as the sound meter and stopwatch. This aids a lot in obtaining the best results since the tripod will not move, making it easier to get more precise data. Secondly is SLM app, or also known as the sound meter. A sound meter is a device that is used to measure the sound intensity and to identify potential noise hazard. It is usually expressed in units of decibels, dB, and the design is created to respond in the same way as the human ear in order to reproduce measurement of sound pressure level, SPL. The purpose of the sound meter in this report is to measure the loudness of sound at the Anjung Sri. Moving on to stopwatch, which we use also mobile phone. Stopwatch is a device that is used to measure time in a certain period that elapses between its activation and deactivation. It usually comes with a start, stop, and reset button. The stopwatch in this report is set for every 1 minute for 30 minutes to measure noise produced by entities. Last but not least, tablet or notebook. A tablet is a computer input device that can be used for multitasking, while a notebook is a medium that can be used to collect data, write notes, and many more. The data obtained was collected in a tablet sheet to be observed and recorded. So now, let's move on to the next slide.
Hi, my name is Khairunisa Binti Norhardi. Now I will talk about location of our case study, which is Anjung Sri. For our study, we choose Anjung Sri as the measurement location. Anjung Sri is a central open space at UiTM Samaran 1 located near lecture halls, residential college, and other main campus buildings. It is a popular area for students and staff to relax, socialize, eat, and pass through on their way to classes or hostels. We choose this place because it represents a typical and busy campus environment. For example, during lunchtime or class transition periods, many people gather there to chat or walk through, which contributes to various background noise such as footsteps, conversations, and occasional vehicle sounds from nearby roads. This makes it an ideal spot for us to capture real everyday sound levels rather than artificially quiet or isolated conditions. Choosing these locations affect our data by giving us more realistic and accurate reading of the noise that students and staff actually experience daily. The results from the location are more meaningful because they truly reflect the actual campus atmosphere. We carried out our measurement on a weekday during the afternoon. On a weekday afternoon from 4:30 p.m. to 5 p.m. The weather was clear and slightly warm, and the wind speed was low to moderate, so there was minimal interference from wind noise. The 30-minute continuous measurement allowed us to capture sound level variations in real time. We observed activities such as people talking in groups, talking on the phone, shouting, and someone dropping a water can. These activities caused noticeable fluctuations in the recorded sound levels, reflecting a lively and realistic campus environment. Overall, these factors help us collect accurate data and better understand how human activities and surrounding conditions affect the noise levels at Anjong Seri.
Hello, my name is Nurain Wafiqah Binti Dzulquornain. I would like to say thank you to Lisa. Now we may proceed to our noise level measurement procedure, which will be shown in the next clip.
The accurate reading for our data gathering, the noise measurement test needs to be carried out carefully. One method of precaution is using a reliable and calibrated app. For gathering accurate data, it is the first and most important step by selecting a trustworthy and a well-reviewed application. Some may display inaccurate data due to poor programming or lack of calibration features, which is why we begin our measuring noise level by downloading a sound level meter app that uses our device built-in microphone to detect and show sound levels in decibel. Identification of location is the next step in measuring noise level. It could fall into one of 5 categories, which is commercial, industrial, residential, silent, or mixed. In our case, Anjong Seri is a mixed location. Step of precaution for this is to make sure to mount and position the phone steadily. By placing the phone on a tripod, make sure it is a flat and sturdy platform. Then don't forget to securely lock the legs to prevent any movement from affecting the accuracy of readings, since hand-holding your phone while measuring introduces vibration, body noise, and inconsistent microphone positioning that could compromise accuracy. We started the noise measurement test at 4:30 p.m. and record until 5 p.m. By using a tablet, we record the readings of sound pressure level per minute for all of 30 minutes. We also jot down the minimum, average, and maximum decibel levels at the end of every 5 minutes as shown on the application. We also make sure to keep the phone in a fixed position and avoid extra noise. Other step of precaution we must follow while conducting the procedure is to stay away from reflective surfaces. Sound can bounce off this, such as walls, fences, that can lead to false high readings. To avoid this, place the phone from at least 3.5 meters away from any large reflective surface and choose an open area for measurements like a field, sidewalk, or parking lot. Lastly, do not interfere during recording because professional recommendations suggest measuring from a distance for at least 1 to 2 meters to avoid distorting readings that can caused by the operator's movement or speaking.
For the results of our study, we measured the sound levels at Anjong Seri UiTM Samarahan 1. Using the sound meter application, the measurement was conducted from 4:30 p.m. to 5 p.m., covering a 30 minutes period in total. We recorded 30 data points with one reading taken each minute starting from 4:31 p.m. During this period, there were no major interruptions and the data accurately captured the natural variation in sound levels caused by different activities in the area. We observed sound levels ranging from 51.4 decibel to as high as 66.6 decibels. The lower readings usually occurred when fewer people were present or during quieter moments. For example, sound levels around 51 or 53 decibels were recorded when the space was less active. Meanwhile, higher readings were mainly influenced by more intense activities. For instance, the highest reading, 66.6 decibels, was recorded when people were shouting. Another significant peak of 64.2 decibels happened when someone dropped a water can, and a reading of 63.2 decibel was measured when someone was talking on the phone while passing by. Overall, this result shows that the sound levels at Anjong Seri are strongly affected by human activities such as walking, talking, laughing, and other sudden noise. The measurements reflect a typical open campus environment where different background sounds continuously fluctuate depending on the time and activities happening at the area. The measurement reflects a typical open campus environment where different background sounds continuously fluctuate depending on the time and activities happening around the area. This data helps us better understand the real noise conditions experienced by students and staff on campus.
Now I will explain about the discussion and findings while conducting this measurement test. So, the World Health Organization, WHO, has standard guideline for noise to be followed, which is we will show in the table. So, it is crucial to follow the standard guidelines to ensure comfort for the users around the facilities. This also includes hearing protection, clear communication, and also to optimize the sound system performance. So the result obtained from the noise level measurement is compared with the guideline to observe the suitability of the sound pressure level SPL at our chosen location, which is Anjong Suri at UiTM Sarawak. The noise level measurement was conducted at Anjong Suri UiTM Sarawak branch Samaran Campus 1 from 4:30 p.m. to 5 p.m. Considering the location and the cross comparison, we can conclude that the result from our measurement is parallel to the 6 specific environments stated in the table, which is school, playground, and outdoor, where the standard limit as per the guideline that has been set by the WHO is at 55 LAEQ, which is the equivalent continuous A-weighted sound pressure level decibels. As for the LA max, which is the maximum A-weighted sound level measured during a specific period, using a fast time constant decibel, the number was not specified since the sound from the environment can vary. As for the obtained result, it is shown in the table.
In conclusion, natural landscapes elements like trees, grass, and open space play an important role in controlling noise levels in public areas. Even in busy environments, these features help absorb sounds, reduce acoustic reflection, and create a calmer atmosphere. An open design concepts also allows sounds to spread naturally without strong echoes, making the space more comfortable for users. This shows that with proper design, focus, and acoustic comfort, public space can be both functional and peaceful. By combining natural elements with thoughtful spatial planning, we can improve overall well-being and comfort in the built environment. As a recommendation, the use of water fountains can be very effective in reducing noise level in public space. The sounds of flowing water helps to mask unwanted noise and creates a calm, relaxing atmosphere for users. In addition, water fountains can act as a physical barrier that absorbs and distorts sound waves, which helps to reduce the overall intensity of noise in the area. This makes water fountains not only an aesthetic feature but also a functional element in improving the acoustic comfort. Another effective way to reduce noise in open area is by using landscape elements such as trees, grass, and shrubs. These green plants act as natural sound absorbers, helping to block and reduce unwanted noise from the surroundings. When placed strategically, they can create a calmer, more relaxed environment while also enhancing the beauty of the space. This shows the greenery is not only for decoration but also plays an important role in improving acoustic comfort in outdoor areas.
Now we have reached at the end of the presentation. Thank you for your attention, and one more time, thank you.
Thank you.
Thank you.
Yay!